Hi, my name is Tom. I'm an educator here at SciWorks, and today I'm going to show you how to make a fizzy pumpkin. So safety first, let me put on my goggles, and let's take a look at a few of the ingredients you'll need to make this pumpkin fizz.
We'll be using 1 cup of 6% hydrogen peroxide. You can usually pick up 6% hydrogen peroxide at any local beauty supply shop or hair salon. We'll use a couple of squirts of dish detergent and a couple drops of this food coloring. And over here we're going to use 2 tablespoons of dry yeast and 6 tablespoons of water. When we mix together the yeast and water, we'll get something that looks a little like this.
So let's start out by putting the hydrogen peroxide here into the pumpkin. That goes in there. Let's take some dish soap, put it in with the hydrogen peroxide. Add a couple drops of food coloring. And when we add the yeast and water to it, there should be a chemical reaction that takes place. And let's see if we can notice that chemical reaction. Look at that, the pumpkin's fizzing all over the table. The reason why the pumpkin is fizzing all over the table is because the reaction between the yeast and the hydrogen peroxide is releasing some oxygen. And that oxygen is getting trapped in all the little tiny millions of soap bubbles that you see here that are spreading. And if you do this experiment at home, another thing that you might notice is that it's warm to the touch. So this is a chemical reaction, and it's also called an exothermic reaction. That means it's a chemical reaction that gives off light or heat, kind of like a fire would, right? A fire, you're burning something and it gives off heat. The same idea goes for this. Naturally, if you were to let hydrogen peroxide sit, it would separate into water and oxygen. And what we did here is we used the dry yeast as our catalyst to speed up that reaction and separate the water and oxygen that got caught in these little dish soap bubbles faster than it normally would. So again, my name is Tom. I'm an educator here at SciWorks, and this is another demonstration you can try at home.